Welcome to Fineline Prototyping. My name is Rob Connolly. I'm president and co-founder of Fineline. Fineline Prototyping is a rapid prototyping and manufacturing service organization. We're located in Raleigh, North Carolina. We've been in business for about 7.5 years. Industries that we serve currently are medical devices, electronic devices, handheld consumer electronics, as well as aerospace and automotive in some applications. The processes that we have here on site are stereolithography, selective laser sintering, 3D printing, and a couple of offshoots of those technologies, one that we call microfluidic fabrication and another that we call SL armor. And I'm going to show you some parts that are made from each of these processes. High resolution stereolithography. And here's a little tiny connector that's an example of what we can do with some of this equipment. This connector is only about 3/8 of an inch long and has little tiny holes and channels in it. It's an example of the fine features and high detail that we can do with stereolithography. In the same kind of equipment, we can make something that we call our microfluidic fabrication. There's a tiny little plate here used for microfluidic purposes, and we can make this in a special way to be particularly accurate and good for testing. Our high resolution equipment can also do things like scans of human hands or other pieces. They're high resolution, can really show detail nicely. On the same kind of stereolithography equipment, we can make things that are truly enormous in size, like this vane ring for a gas turbine engine for aerospace applications. This vane ring was made in one piece, and it has very large features on it, of course, and it also has very small features that are hard to capture. Our SL armor product is something that we use. We build it in stereolithography out of a ceramic filled polymer, and then we plate it with nickel. The nickel plating is built up to a structural thickness to allow it to have a structural strength, a lot stronger than a standard stereolithography part. And you can see that it still preserves fine details like the little threads on this piece. Here's another example of that. This is a little bottle cap opener made in SL armor. This is something that's very strong and stiff after it's been plated with nickel. Another application of stereolithography is called quick cast. This pattern here was made in a special imaging style that results in it being hollow on the inside. It has over 80% air on the inside of it, but the geometry on the outside is exactly what you have designed for your part. Using this process, this can be used for investment casting purposes. The pattern gets sacrificed when it's burned out from the investment casting. We pour in metal and you get a part that looks just like it, only it's in metal. All the features that you had in the part, only now they're metal. You see, this is a high performance nickel alloy, and you would otherwise have to machine a very expensive tool to make a part like this. Selective laser sintering is similar to stereolithography in that it's a layer and laser based process. Although rather than the laser drawing on a liquid photopolymer, it actually draws on a bed of powder, and it can make a part that's much stronger and stiffer than a stereolithography part. The part is a little bit more of a rough surface finish on it, but it's very high performance in terms of material properties. These can withstand ultraviolet exposure, high temperatures, moisture exposure without degrading, whereas stereolithography can't take that sort of abuse without some degradation. Here's an example with a living hinge, this selective laser sintered part. This is something that you can't do with normal stereolithography or many other parts.